Alright, let's do a little bit more compiler development. The last video we implemented strings like this, and we can just make strings, but now we're gonna define some operations on these strings. So the first thing is probably to print strings a bit nicer, because if we do something like this, we just get this. So that's not very good. And where does this happen? It happens inside the run function. Here when we print the last thing. So let's define a function, print value, which we might put in here. Actually, let's put it right here, print value. It's a procedure that takes a value and it just prints it. So let's say switch val and value. So kind of forgot again how switch statements work in this language, which is great. Keep forgetting that. Okay, so if it's nil, then we will print nil. Let me disable Copilot because it's annoying me right now. Anyway, if it is a Boolean, then we will print f, and we will print this and just the value, and we don't need semicolons in this language. If it's a number, can we do something like this? Print it with only four decimals. And if it's an object, now something interesting will happen. We have this array of bytes. So let's say string value. This should do it, because it's still a union. So we get the string value. Now this guy should have type string, and then we can say let's just call it str. That will be string value data as string. Then we'll print that with this stuff wrapped around. Let me check the run function one more time. Alright, so we did something kind of funky here, and let's just get rid of that. Right, so here we have something. Let's try to run that, and it completely exploded. And you don't, this is not how you do casting, I suppose. Is it like this? Line 37, and it's also not like that. I'm just really messing up. Okay, 45. And And this is not how you do casting. So how do we cast things? I think there's something in here. It's just called cast. So let's cast this to a string. And we have to say import. And now accidentally I undeleted that. Okay, finally, let's see, 1, 2, 3. And it prints like this, but that is not fully correct. We need a new line as well. And now we can say 1, 2, 3, and it prints as 1, 2, 3. You can see we have it stored here, some more complex things. So now let's check equality. Can we do equal? And we can. I kind of forgot that I implemented that. So let's see here. Equal and run equal. Yeah, it will run this string equal. Great. So now let's add string concatenation. We'll go here to run again. And if we see, by the way, it's not implemented right now. It will just fail. But if we see an add, we're gonna run add and it will get 2 values here. So we need another case here. So in the case that it's an object, we're gonna do another partial, well, let's just do a switch for now. We're gonna do another switch on, let's call it object value in value A. And in the case that this is a string, we will, this will be a string value. Then we can say string B, okay, equals, well, we have to say object B, okay, is B as an object, and then we have to try to get the value out of that, the string value out of that. So so if not, okay, then we have a problem because we cannot concatenate a string with something that's not a string. So we're going to return false. Operation failed. Now down here it is okay. So again, if it's not okay, if B is an object but not a string, then again we cannot do anything about that. But here it's both of them are a string. So I want to make a new string. Let's call it concatenated string. So it's supposed to be a string, and we can do something like this, I think. We can say the length is the length put together, string B, the length, and let's call it conc instead. So the conc data is a new array of U8, and let's say new length, the conc length is this thing. this guy is like that. And now we need to fill it. Also forgot how for loops look. I really should stick to one language. Great. Okay, so we made a new string, and let's push that to the stack, but we have to do some kind of acrobatics like we do here. Yeah, we have to say value is cast to value and cast to object of the concatenated string, and then we can push it onto the stack. And that should do it. Let's try to compile it. Probably will not compile. Because you don't do dots in this language, that's a C thing. Cannot assign, right, because it's the const length. You cannot redeclare, you cannot shadow things. And missing return statement. Okay, so here if we return, if we do this, it's okay. So we will return true. And I suppose any other case, we will just return false. Now let's try to concat. Amazing. All right. So one thing we should probably add as a note is that we have made some memory here, and how do we get rid of that? And also, how about this memory, these strings that we just popped? Maybe this is where we free them. So I will also add a to-do here. Yeah. So actually these compiles, oops. Here we make a new array, so we're actually allocating new memory, and we are copying the memory. Okay, so this needs to be freed. Any string we make needs to be freed at some point. Okay, actually there's a good point in the book, which is that it won't be right if we free memory here, because the memory is kind of living in the constant section of the program. Let's see what I mean. Let's try to do this. So we have this section of constants, And in principle, even though we add them together here, the data should still live, because further on there could be more instructions that use those particular constants. So what we're gonna do now is to not to free them yet. We'll be making a garbage collector later, but just to keep track of every object that has been allocated. And we'll apparently do that by making a linked list. So the way that's gonna work is the object will become a linked list. Okay. That is not amazing. That is not amazing. Because, how do we do that? Now I basically want something like this. A struct that has the original object inside it. So let's call it object value. And then it has like the next object, which is a pointer to this new thing. So I guess we'll do this. No, that one was supposed to be there. Yeah, so now we're gonna get a bunch of compilation errors. Let's start in here. So we just made a string. Let's actually follow along with the book, because I just cannot think about this right now. So the VM will need a pointer to the start of the linked list of objects. So there we go. When we initialize the VM, we need to set that to nil. There we go. Each time we allocate an object, we insert it in the list. Okay. I don't think we have this allocate object. So that is great. Have diverged. Okay. So here we just manually make the object. Right, so let's go back into value, and so this will be what we now call object value. So let's make the actual object. That's going to be an object, and the object value will of course be the string object value. And the next object will be nil. Then let's not call it allocate, because that's not really kind of what we're doing. Let's call it track object. So we'll do this thing. probably we have to cast this to an object value. And there we go. So now we just need this track object function. Let me go back here. So track object, it takes some kind of object, which has to be actually an object. Then we will have a look at the VM. So if vm.objects equals nil, then, you know what, we don't need to do that. We will say object.next object equals what's currently on the top, and then this will point to you know what, let's return it. Is it like that? So that should work, but probably not. So now there's some stuff in this function. Okay, right. So in case it's an object, then we have to do val dot object value if it's a string. So let's see if that did something. It did something. So let's go here to 94. Right. So that one is okay. Can I have to intercept everything? So object value, that object value. It's amazing. Wait a second, so switch. Okay, so let's just, this is all we need to do actually. We switch on the object value, and B is just something that should do it. Right, then 121. Okay, here we have string, so let's call it concatenated object. Should be an object where the object value is the string. The next object is null. And then we add it here. And 250. Right, okay. There we go. Seems to be running. Illegal instruction. Amazing. Amazing. So let's take a look at print value again. Weird. Just as a sanity check. Right, so it's not that. But where does it actually happen, this problem? I mean, I think this, let's comment this out and let's just see what happens. No, it's not that. Which means that it's probably in the disassemble code. So what if we just return 1, 2, 3? And it doesn't like that because it's annoying. Okay, so it is somewhere in this code. Now let's see, it should have to do with get value type string. What did I just do? Okay, there I think we're good, and now there's no changes in this file. Perfect. Okay. Index constant. Is it this part? It seems to be this part of the code that is causing some kind of issue. Right. The weird thing is that we okay, that's also wrong. Index 1 is out of range. What index is that? What index is it talking about? So even just printing but where's this called from? Probably in here. No. I mean, it must be in main, right? This main. I am so confused. It's none of that stuff. This just runs it. So where is it? Is it inside the compile function? Yeah, okay, so here we go. Created of output. Yeah, so I still don't get it. Let's try something. So if it is an object, maybe this is better like named like this. So if it is an object, then we'll do something a little bit different, which is constant object at object value. Okay, so it's just that there's some kind of problem if you try to print something that has nil in it. Okay, just as a final thing, let's go into here and in the interpret function, let's just for fun let's say let's try to count how many objects have been allocated. So we'll do something like this. Every time we see something that's not nil, we increment this, and then we set this to the next object. Then we're going to print that. Printf allocated objects in total count. Let's try to do this, and it's segfaulted. Oh my god, it's not my day today. It's segfaulted again. But if I print it, there's somehow no reason, no issue. So this track object should be called a bunch of times. Tracking objects. Fuck. It should be called 2 times. So it is called 2 times. So does the VM even exist at this point is perhaps the question. Yeah, we do initialize the VM and then we start doing things. Come on. Come on. But actually, that should be fine. Okay, I actually don't know what it is. So what we're going to do instead is we're going to make a dynamic array of objects. But this is like really making me reconsider this language. So we're tracking an object. Let's append to the objects, and what are we gonna append? We are gonna append this guy. So let's just make it a bunch of pointers. Maybe we don't need to do that. Let's go in here. It's fine for this thing. Okay, whatever. You're not gonna get, okay, so this should be it should be undone, that stuff. So we just append, and here we're just gonna say count is the length of the objects. Okay, so line 28, don't need that, and 187, this one is gone as well. Okay, now we at least the count is correct and everything. Right, so I think that's gonna do it for this time. So I will see you in the next one.